What we witnessed with 3I Atlas was an explosion of light and energy 10 times brighter than predicted. An event unlike anything we've ever seen. This wasn't random. Something powerful, either deep within its core or an external impact, triggered this cosmic detonation, revealing the secrets of another star system. It exploded in brightness. Without warning, the interstellar wanderer 3I Atlas went from a dim, distant object to a brilliant beacon in the night sky. The flare was 10 times more powerful than anyone predicted, leaving astronomers scrambling for answers. You see, this is more than just a celestial firework. It's a clue. This object has traveled for millions of years from another star system, carrying secrets from its home. And that sudden violent flare-up, it just told us something profound is happening out there. And we need to figure out what it is fast. The outburst no one saw coming. As 3I Atlas crossed the invisible line of Mars' orbit about 140 million miles from the sun, it woke up. And it didn't just wake up, it exploded into the spotlight. In a matter of hours, the comet's brightness surged, increasing by a factor of 10. This wasn't a gentle brightening, it was a violent, sudden flare. To understand how shocking this is, you have to know how comets work. You see, they're essentially giant dirty snowballs, leftovers from the formation of a solar system. They are a mix of ice, dust, and rock. As they approach a star, the heat begins to vaporize the ice, creating a glowing cloud around the core called a coma and a tail that streams away. This process is usually gradual and predictable. Scientists have models that are incredibly good at forecasting how bright a comet will get. For 3 Atlas, those models were torn to shreds. The flare was so intense that it immediately caught the attention of observatories around the globe. This was a 5-alarm fire in the astronomical community. The initial data suggested something catastrophic had happened to the comet. An event of this magnitude points to something more than just a surface pocket of ice bursting in the sun. It hints at a deep structural change within the comet itself. World-renowned physicist Michio Kaku has pointed out that events like these are cosmic laboratories. He explains that we are seeing physics unfold in real time on a scale we can't possibly replicate on Earth. This isn't just a light show, it's a message written in the language of energy and light, telling us that this visitor from another star is unlike anything we've ever seen from our own solar system. This flare didn't just make the comet brighter, it lit up a massive question mark in the sky. The data pouring in is absolutely mind-boggling. The cloud of gas and dust, the coma, expanded at a blistering pace, growing to a diameter of over $60,000 meter in a single day. That's nearly 8 times the diameter of planet Earth. The sheer volume of material ejected into space is staggering, estimated to be in the millions of tons. This wasn't a leak, it was a detonation. The thing nobody tells you is that this material, now glowing brightly under solar radiation, is a treasure trove of information. By analyzing the light from this cloud with instruments called spectrographs, scientists can determine its exact chemical makeup. This gives them a direct sample of the stuff that solar systems are made of. Not our solar system, but the 13I Atlas came from light years away. It's like receiving a package from an alien world. And this package just burst open for all to see. But this incredible flare is only the beginning of the mystery. What could have possibly caused it? A mystery deep in the core. So what could possibly unleash this much energy from a frozen rock? Scientists are scrambling, but a few leading theories are emerging, each more dramatic than the last. The first and most straightforward idea is that the comet simply fell apart. The nucleus, or the solid core of the comet, might have fractured under the increasing thermal stress from the sun. Think of an ice cube you pull from the freezer and drop into a glass of water. It cracks and splinters. Now scale that up to a mountain-sized object made of ancient ice and rock, trillions of miles from home, being heated for the first time in perhaps millions of years. A sudden catastrophic breakup would expose a massive amount of fresh ice to the sun all at once, triggering an explosive release of gas and dust. But not all things are what they seem. While fragmentation is a solid theory, some experts, including those inspired by Michio Kaku's way of thinking, are looking at more exotic possibilities. One idea is that 3I Atlas has a very strange composition. Comets in our solar system are mostly made of water ice. But what if this interstellar visitor is made of something far more volatile? What if its core is rich in frozen gases like carbon monoxide or nitrogen? These substances turn from solid to gas at much colder temperatures than water. As 3I Atlas approached the sun, it could have hit a boiling point for these super volatile materials buried deep inside. This could create immense pressure under the surface crust, eventually leading to a massive violent eruption like a cosmic geyser going off. This would explain the suddenness and sheer scale of the flare far better than a simple crack. Then there's the truly wild card theory. It wasn't an internal failure, but an external event. What if 3I Atlas didn't act alone? The space between Mars and Jupiter is home to the asteroid belt, a chaotic shooting gallery of millions of rocks. While space is vast, collisions do happen. Is it possible that 3I Atlas was struck by a smaller unseen object? Even a small impact, say from a 10-feet wide asteroid hitting a volatile comet at a combined speed of over 100,000 mph would release an incredible amount of energy. It would be like hitting a bomb with a bullet. Such an impact could have shattered the comet's surface and triggered the massive release of material we witnessed. The problem with this theory is the lack of a smoking gun. We haven't seen any evidence of an impactor. But in the vastness of space, the evidence is not always easy to find. Dr. Kaku often emphasizes that we must remain open to possibilities that challenge our assumptions. The data from the flare is still being analyzed, and it holds the key. The shape of the expanding dust cloud, the speed of the ejected particles, and the specific chemical signatures will all serve as forensic evidence. If the cloud is asymmetrical, it might point to a localized eruption or an impact. If it contains exotic chemicals not typically found in our comets, it supports the unusual composition theory. Every photon of light captured by our telescopes is another clue in solving this incredible cosmic whodunit. The flare has given us a puzzle, but it has also given us the pieces we need to solve it. As scientists race to understand the cause, the comet itself continues its journey toward a fiery destiny, running toward an inferno. The event that triggered the flare may be over, but the journey of 3 Atlas is far from finished. In fact, the most dangerous part is yet to come. Right now, the comet is hurtling toward the sun at a staggering velocity of over 150,000 mph. That's fast enough to fly from New York to Los Angeles in just 1 minute, and it's still accelerating, pulled in by the sun's immense gravity. The climax of this journey is an event called perihelion, the comet's closest approach to the sun. For 3I Atlas, this will happen in late October when it will pass within the orbit of Mercury, just 23 million miles from the sun's blistering surface. At that distance, temperatures will soar to over 800 degrees F, hot enough to melt lead. This close pass is the ultimate test of survival. The intense solar radiation will be like a blowtorch aimed directly at the comet's core. Any weaknesses in its structure will be ruthlessly exploited. Many people are crazy about the idea of seeing a spectacular show, and they might get it. There are two possible outcomes, and both are spectacular. The first is that the comet survives its fiery pass. If its nucleus is solid enough, it will weather the storm, losing a tremendous amount of mass as its ice boils away into space. This would create a truly magnificent sight, potentially making it bright enough to be seen with the naked eye from Earth, a ghostly visitor in our twilight sky. It would emerge from its solar encounter, scarred and diminished, but intact, ready for its long journey back to the stars. The second possibility is far more dramatic: total disintegration. If the comet's core was already weakened by the event that caused the earlier flare, the immense tidal forces and heat from the sun could be the final straw. The nucleus could completely break apart, turning the single comet into a brilliant streak of dust and gas, a string of pearls slowly fading as it disperses into space. This would be a tragic end for our interstellar traveler, but an unparalleled scientific opportunity. We would get to witness the end of a comet's life up close, providing a massive amount of data on how these objects are constructed and how they perish. The James Webb Space Telescope and other powerful observatories will be watching, ready to capture every moment of the drama. This encounter is particularly exciting because 3I Atlas is not from around here. It's only the third confirmed interstellar object ever detected after the bizarre cigar-shaped Oumuamua and the more conventional comet Boros. Oumuamua was gone before we could get a good look, and Borisov stayed too far from the sun to put on a real show. 3 Atlas is giving us the best of both worlds. It's an interstellar object making a daringly close pass of our star. What we learn from its behavior at perihelion will set the standard for our understanding of comets from other star systems for decades to come. Every piece of data is a page in a book we've never been able to read before. The fate of 3I Atlas hangs in the balance, but its legacy is already being written in the stars. Clues from another world. Regardless of whether 3 Atlas survives its encounter with the sun, it has already changed the game. The sudden violent flare has forced scientists to rethink their assumptions about interstellar objects. It's a stark reminder that the universe is more complex and surprising than our models can predict. Michio Kaku often speaks of the need for new physics to explain the deepest cosmic mysteries. And while this event might not require a rewrite of Einstein's laws, it certainly proves that the variety of objects floating between the stars is far greater than we ever imagined. This comet is a messenger, and its message is that we have a lot to learn. What's the core message? The chemical data from the flare is revolutionary. Preliminary analysis shows ratios of certain gases and elements that are different from any comet ever observed from our own Oort cloud. This provides concrete evidence that the stellar nursery where 3I Atlas was born was chemically different from our own. It's a direct fingerprint of another solar system's composition. For years, we have wondered if our solar system is typical or unique. Objects like 3 Atlas are the only way to answer that question. They are time capsules from distant stars, and this one just gave us our best look inside yet. The thing nobody tells you is that this data will be studied for years, feeding into new theories about how planets and ultimately life might form in other corners of the galaxy. As for the speculation, it's important to separate science from fiction. While the idea of the flare being triggered by alien technology is exciting, there is absolutely no evidence to support it. Science operates on evidence, and all the data currently points to natural, albeit extreme physical processes. The theories of fragmentation, volatile composition, or a random impact are all grounded in the known laws of physics. The final verdict on what caused the flare will come from careful, meticulous analysis of the data collected by telescopes on Earth and in space. The beauty of science isn't in jumping to wild conclusions, but in the patient, collaborative effort to solve a puzzle. 3I Atlas serves as a profound demonstration of our place in the cosmos. We are a tiny civilization on a small rocky planet, yet we have built the tools to see a mountain of ice from another star system flare up from a distance of over 100 million miles. We can analyze its chemical makeup and predict its fiery destiny. This visitor has reminded us that our solar system is not an isolated island, but is connected to a vast interstellar ocean. Other objects like 3I Atlas are out there right now, silently sailing through the void, and some are headed our way. The era of interstellar astronomy has truly begun. We are witnesses to a cosmic event that will be talked about for generations. Was the flare a warning or just a random act of nature? Like and subscribe for more cosmic mysteries.